Agents, artificial intelligent agents, and multi-agent systems. This is what we are going to talk about next 45-ish minutes. And let's try to imagine multi-agent systems in action. I'm Maxim Salnikov. I'm based in Oslo, Norway, where I help developers to succeed with our Microsoft's cloud, artificial intelligence, and developer tools, products, and solutions. I'm personally building on web platform since late 90s, so over 2 decades. And I'm fully committed to enabling our customers and communities in the topics I personally love the most. And I have some expertise in. It's web development, all flavors, cloud development, generative AI, and prompt engineering. And it all 100% related to our today's big topic, agents and multi-agent systems. But first, let's try to understand how we got there. Past 30 years, world has seen 3 major platform shifts, from client-server era to internet to mobile and cloud, and today we are in the midst of 4th platform shift. Of course, I'm talking about AI. Every platform shift has required business leaders to think differently and also technical leaders to think differently. But there is one big difference in today's platform shift, and this is pace of the change. If we double click on this AI platform shift, first of all, in many senses, it's around generative AI, this very particular subset of artificial intelligence. And it also had its own stages. But of course, like before on previous slide, it was like decades. Now we talk about years, maybe months. So started with a broad adoption of what we could call AI assistants or copilots, very promptly moved to agents era. Currently, today, this is all around multi-agent systems at the forefront of innovation. And who knows, folks, what will happen tomorrow. So if we meet in 1 year on the same conference, on the same stage, let's see what we could put instead of this question mark here. And opportunity for artificial intelligence, in particular autonomous artificial intelligence, is growing. So some survey, some research shows that in just 3 years, at least 15% of day-to-day work decisions will be taken by agents, by AI agents. You might say, okay, 15, this is not something really big, but compare it to 0% in 2024, just a year ago, and that's significant growth. And before we dive into details of multi-agent systems, let me make sure that we are on the same page in understanding what is AI agent and its key features, because this will help us to move forward to talk about multi-agent system. First of all, if we look at the, let's say, lowest hanging fruit AI agent use cases, just categorized by this 4 pillars: travel booking, employee onboarding, all kinds of personalization, including customer support, data analytics and reporting. I mean, I'm not going to go through all this busy slide. I just highlighted some of these use cases, and part of this use case is just for you to clearly see that every single use case for AI agents has verb, has action, and it differentiates AI agents from all other kinds of, let's say, AI experiences, generative AI experiences. So, and all definitions are very different, right? Ask 10 different people what is AI agent, you will get 14 different definitions. But still, to be on the same page, how I understand what is AI agent, this is software. And yeah, I'll double down on the fact that it's still software on my next slide. So this is software that we give a goal to, like aim, and it works itself, right? So without us knowing in advance how it will do this its stuff, and it's kind of black box, right? So we explain what we want in natural language, in human language, and then thanks to the magic of large language models and some software engineering practices, we get results, we get what we want, but we are not very interested what happened under the hood, right? Of course I'm talking about not very interested from a customer perspective. As developers, we are very interested. It's all about monitoring, observability, etc., etc. But that's slightly different story. Back to the fact that it's still old software engineering. What I see today in production-ready agents or agent systems, 80% at least, maybe even more. This is traditional software engineering practices. So they are not discarded. They do not disappear at all. Just on top of that, you need some extra knowledge, some extra practices, some extra efforts, how to add generative AI capabilities to really make sure that this is not kind of algorithmic software, but what you could call AI agent. And about complexity, it's absolutely no need to start your AI agent journey as a developer or as a customer from the most advanced one, like fully autonomous, completely automated, based on some triggers. No, I mean, if you created proper chatbot, properly landed or grounded on your, let's say, enterprise knowledge database or enterprise databases, and for example, if it has the only single action to call for human agent in case of needed, we already can call this an agent, right? I mean, complexity is a spectrum. You don't need to start with the most advanced ones, and I will double down on that when we go through multi-agent systems. And also, this is how we in Microsoft understand agents from kind of input-output perspective. So input could vary. It could be a message in human language. It could be a message from another agent, and we'll talk about this as well. It could be some system trigger, and then in the agent itself, first of all, to understand what's needed to be done, we use power of generative AI. It's power of understanding of human language, of our natural language. Then we use power of prompting to basically explain to this agent or to this LLM behind this agent how to execute this, which tools to call. And tools, this is paramount of everything. This is, I mean, there are no agent without tools, right? And tools could be very different. It could be just data sources. It could be concrete actions like triggering API or doing something on your local machine, like running command in terminal. I mean, different agents have different actions. And outputs, of course, we expect either some message back or another agent trigger it or some action performed. And also, if we talk about real agents or kind of agents in its full understanding, they do not only reason and act, they also learn. And this is why it's super important for agents to have memory, both short-term memory and long-term memory. But again, this is not something you need to think from the very beginning if we talk about some simple use cases. So let's don't over-engineer and use proper tools for proper cases. And very important to have some considerations when you start building AI agents. First of all, think about knowledge, how you equip your AI agent with the right context. Actions, how you provide proper tools. Again, tools could be very different. from triggering some API to creating, for example, file on your local system. And I mean, the sky is the limit here. Evaluation is totally different story when you talk about any kind of, not only AI agents, but also any generative AI infused applications. It's very different from what we used to have in, again, old, for example, unit testing, where it's either failed or not failed. Right now, it's kind of it depends. It's spectrum, like from 1 to 0. It could be bad, it could be okay-ish, it could be good enough, and maybe you need to define thresholds. So you need to try to understand what could be measured and how to measure this and how to take decisions based on that. And foundation of everything is security. If we talk about proper agents equipped with actions, wow, this is where, I mean, you don't want agent to have access, first of all, to some data it should not see, but even more important, you don't want agent to perform actions that it's not allowed to do. So security is not addition, it should be always in the foundation of every single agent journey. And to demonstrate this in a very simple level in practice, we can think about, okay, agent that helps us to fix our washing machine that started to produce strange sounds, right? And just imagine that we as customers refer to some chatbot or phone support. I mean, it could be in different forms, right? Thanks to generative AI, we have great text-to-speech, speech-to-text, everything. It doesn't matter the exact way, but let's say that we chat with the agent, AI agent, not human agent, and this agent, based on our initial request, can trigger different tools, like, for example, know your customer tool, to make sure that this agent has full context about us as customer, about products we bought. Tool number 2 could be a documentation tool that knows everything about this particular model of the washing machine, and the agent can understand what kind of washing machine we have just by, for example, again, back to know your customer tool, thanks to order history. It can check logs from this log machine, like definitely it should be a different tool. Schedule the next appointment or call is the next tool. And I mean, you see that in this particular example, there is one agent equipped with multiple tools. And that's completely valid scenario. And this is kind of in the middle of this, again, one more spectrum of the agents I want to introduce, from no agent at all, just a regular request response way to interact with LLM, to multi-agent systems. And everything what I presented was kind of intro to make sure that we are on the same page in understanding what is AI agent, so we can build up on that. Because, folks, it turned out that in today's solutions, AI-driven, AI-infused solutions, especially if you talk about some enterprise scenarios, multi-agent systems are much more relevant compared to single agent that can do everything. And let me try to demonstrate this in action. This is where we begin our story about agent enters the bar. Let's call this agent alpha, and let's pretend that this is actually worker in a bar. Picture this: single, hardworking AI agent running a cozy neighborhood bar. Agent alpha is pretty impressive. It can take your drink order, recommend a perfect cocktail based on your mood, and even process your payment seamlessly. Life is good. On a quiet Tuesday evening, Agent Alpha handles everything beautifully. 5 customers, maybe 10 on good night, each order gets personal attention. The agent remembers, agents have memory, your favorite drink, suggests new recipes, and you might like, and keeps track on inventory, process payments. It's like having perfect bartender who never needs a break. But then Saturday night arrives. The place is packed. We are taking standing room only. Orders are flying in from every direction. And complex cocktail requests, special dietary requirements, payment disputes sometimes, inventory running low, and wow, there is a bachelor party that just walk in with 20 or maybe even more people. Boom, system overload. Our poor agent alpha is drowning in requests. Response times slow to crawl, errors start creeping in, customers are getting frustrated. And this is where our story about multi-agent system begins. Let's break down what's actually happening to our overwhelmed agent. When you have 100 plus customers, all demanding service from a single agent, you are not just facing a volume problem, you are facing a complexity crisis. Think about what agent alpha is juggling simultaneously. Someone wants a molecular gastronomy cocktail that requires specialized knowledge. The inventory system needs real-time updates as bottles empty. Multiple payment methods are being processed. Credit cards, mobile payments, split bills, all these kinds of payments. A customer is complaining they're doing tastes wrong and they want to escalate to the manager. And also security is needed because, for example, someone is too noisy. And this is fundamental challenge with single agent systems. No matter how powerful, how well trained, or how sophisticated your single agent is, it has limits. It's trying to be an expert at everything while handling parallel demands that require different types of expertise and attention. In the real world of AI, this translates to systems that slow down, make errors, or just simply crash when complexity scales. Whether you're building customer service platform, trading system, or enterprise automated solution, this Saturday night problem, let's call it like this, is very, very real. So what's the solution? Well, what would a real bar do? That's right, let's call the team. Ladies and gentlemen, meet the dream team. Instead of one overwhelmed generalist, we bring in specialists. First, we'll have our mixologist agent. This is your cocktail artist, if you wish, deeply trained on thousands of recipes, flavor profiles, and mixing techniques. They don't worry at all about payments or inventory. They craft the perfect drink. Next, cashier agent, a payment processing expert who handles transactions, split bills, manages tips, and keeps the books balanced. They don't need to know anything about cocktail recipes, for sure. Our stock manager agent monitors inventory levels in real time, predicts when supplies will run low, and can even automatically reorder before you ever run into that popular run out of these popular drink components. And our bouncer, they handle security, monitor for problematic behavior, and ensure that everyone has a great time. This is the essence of multi-agent systems. We are taking inspiration from how humans naturally organize complex work. I mean, in many cases, AI agents, they mimic our behavior, right? Each agent is specialized in their domain. They do one thing, but do it exceptionally well. They are autonomous in their decision-making. They don't need constant supervision, maybe from time to time only. And they are collaborative in reaching shared goals. They work together seamlessly. And we in Microsoft has our own multi-agent reference architecture. And this approach mirrors how successful human organizations operate. You don't have one person trying to be CEO, CFO, CTO, and janitor. You build teams where expertise combines to create something greater than the sum of its parts. And this is this multi-agent reference architecture created by Microsoft. And the rest of the session will go block by block, connection by connection in this a bit complex diagram. No, I'm just kidding. This is not a session about that. Let's go. I mean, even though this architecture is super relevant, and I encourage you to learn about that when you start to implement your own system, let's go back to our bar. And let me paint you two pictures. Picture one, the single agent bar. One incredibly smart bartender trying to do everything. They are mixing drinks while calculating bills in their head, watching doors for trouble, and trying to remember if they ordered more virgin mojitos last week. They are jack of all trades, but master of none as a consequence. When they process tasks, it's one at a time, sequential, linear. And if they are sick, Well, bar is just closed. And picture 2, multi-agent bar, a team of specialists. The mixologist is experimenting with a new recipe while cashier processing 3 payments simultaneously because they're expert in this. The stock manager just auto-ordered supplies before anyone ever noticed they were low. Each agent is a master of their own craft and they work in parallel, multiple things happening at once. And if one agent needs some maintenance, well, the others keep the bar running, at least to some extent. And it's not just a theoretical, it's not just imaginary bar, right? Netflix uses multi-agent systems for recommendations. One agent analyzes your viewing history, another tracks trending content, another considers time of day and device. Amazon's warehouse robots are multi-agents coordinating deliveries. Your bank most likely uses multi-agent systems to detect fraud while processing transactions while managing risks. Many things in parallel. The key insight here, in today's complex world, the question isn't how do we build smarter agent, it's how we build smarter team of the agents. Let's talk about why multi-agent systems are becoming the kind of de facto go-to architecture for complex AI applications. Performance. When agents work in parallel, they get true multitasking. While one agent is thinking about your cocktail recipe, back to our bar, another is already processing your payment. In some production systems, this parallel processing can improve response times by several orders of magnitude. Specialization means each agent can be optimized for its specific tasks. You can use different models, different prompts, even different computing resources. Your mixing agent might use a creativity-focused model, while your inventory agent uses precision-focused one, maybe fine-tuned. Scalability is huge. Friday night rush, spin up more cashier agents. Craft cocktail festival in town, add specialized mixologist agents. You can scale what you need when you need. Reliability through redundancy. In a single agent system, one failure means total failure. In multi-agent systems, other agents can compensate. The bar stays open, at least to some extent, even if one bartender is sick. Maintainability changed the game for developers. Need to improve payment processing? Update just a cashier agent without touching the rest. Found a bug in inventory management? Just fix it in isolation. And innovation becomes so much easier. Want to add, for example, sommelier service, just add the wine expert agent to the team. No need to retrain your entire system or risk breaking existing functionality. This is why real-world enterprises are moving to these particular multi-agent architectures. It's not just about handling more load, it's about building systems that can evolve and adapt. Okay, now you might be thinking, this sounds great, but how do these agents actually coordinate? Well, that's a big deal. Excellent question. Think about our bar again. You can't just throw 5 bartenders behind the bar and hope for the best. You need systems, processes, coordination. Who greets the customer? Who makes which drink? Who handles the difficult customer? Who is in charge when decisions conflict with each other? This is where orchestration patterns come in. Just like a well-run bar has workflows, seat customer, take order, make drink, serve, collect payment. Multi-agent systems need orchestration patterns to coordinate effectively. We identified 5 fundamental patterns through our work with enterprise customers. And these patterns are not just theoretical. They are battle-tested patterns running in production systems right now while I present. Each pattern solves different coordination challenges. Some are like assembly lines, other are like brainstorming sessions, and some are really like jazz improvisation. Let's spend some time on exploring these partners. Again, we'll go back to our bar metaphor. Let's start from the simplest one, sequential service. This is your classic assembly line approach. Customer walks in, host agent greets them, understands their needs, table or two, right this way, then host hands off to order taker agent who specializes in menu knowledge and, for example, dietary restrictions. You mentioned gluten-free. Let me show you our options. Order taker passes the complete order to our mixologist agent. This agent doesn't need to know about seating or dietary restrictions, just the drinks to make. They craft the cocktails with precision and maybe even artistry. Finally, the cashier agent handles payment, loyalty points, receipts, everything. Each agent does their part in order, building of what came before. This is exactly how many, for example, document processing pipelines work. Imagine law firm processing contracts. First, template selection agent chooses the right starting document. Then, clause customization agent modifies it based on the real deal. Next, regulatory compliance agent ensures it meets all legal requirements. Finally, a risk assessment agent evaluates potential liabilities. Each agent is an expert in their step, and the output of one's becomes the input for the next. It's predictable, reliable, and perfect for workflows where order matters. Remember, order matters in this pattern. When do you use this? When you have clear dependencies. When step B depends on the output from step A. When you want deterministic, of course, I mean, when we say about deterministic in generative AI systems, this is somehow deterministic. Repeatable processes. Document processing, data transformation, content moderation, these are great examples of where sequential pattern will work good. And if you are visual folks like myself, this slide will help you to visualize the flow from this law firm example that I just demonstrated. You see, chain of the agents, and every agent is expert in their own area. And by the way, they can be connected to totally different models to do just one task, but do it with perfection. Pattern 2, concurrent service. Now things get interesting. Imagine a customer walks in and says, "Surprise me with your best cocktail." And instead of one bartender making a decision, we unleash 3 specialists or even more simultaneously. Bartender A crafts their interpretation using classic techniques. Bartender B creates a modern molecular gastronomy version. Bartender C prepares a local favorite with regional ingredients. All 3 work at the same time in parallel. Then we either let customer choose, blend best elements, or use voting to pick the winner. This is the power of concurrent orchestration. And agents actually don't need to be of all the same time, like in this example. We can showcase this pattern with financial analysis. When analyzing a stock, you don't want only one perspective, right? To make sure that you invest in the right stock. You want multiple agents simultaneously. For example, technical analysis agent examines price patterns and momentum indicators. Fundamental analysis agent digs into financial statements and earnings and all history around that. A sentiment analysis agent checks news and social media, also super important. And the ESG agent evaluates environmental and social governance factors. All 4 agents work in parallel because they don't depend on each other, right? And they examine the same stock ticker from their unique expertise. The results are then aggregated into comprehensive investment recommendation. This pattern really shines when you need diverse perspectives fast. Brainstorming sessions, risk assessments, creative tasks, anywhere multiple viewpoints add value. The key is having a smart aggregation strategy. What happens next, right? How do you combine 4 different opinions into one decision? That's where the magic happens. Real world example, every time you search on internet, multiple agents are analyzing your query simultaneously. Web results, image results, news, maps, all running in parallel and then aggregated into that familiar third page results. To visualize this example, we can draw a diagram like that. So you see, we start multiple agents running in parallel. Furthermore, it could be multi-step. So you see that this fundamental analysis agent in its turn splits into 2 even more specialized agents. This is about concurrent pattern. Now, pattern number 3, group chat. This is where agents stop being solo and start being a real team. Picture this scene. It's Monday morning and the bar's management team is discussing whether to add an expensive craft cocktail to the menu. The mixologist agent starts, This cocktail would showcase our expertise and attract cocktail enthusiasts. The financial analysis agent jumps in, but the ingredients cost $30 per drink. Our margin will be only 15%. The marketing agent responds, yes, but it would position us as premium destination. We could feature it on social media. And in its own turn, inventory agent warns some ingredients have 3-week lead times and short shelf life. They are not working in isolation. They are having real conversation, building on each other's points, challenging assumptions and reaching consensus. And we need manager, right? A chat manager agent orchestrates who speaks when, not to interrupt each other, ensures everyone contributes, and can even bring in a human owner for the final decision. We need human in the loop in many cases. Many companies, many enterprises implement this for complex decision making. Let's take, for example, park development. Environmental agents discuss ecological impact, while budget agents debate costs, and in their turn, community agents advocate for accessibility. It's collaborative problem solving at its finest. This pattern is super powerful for scenarios requiring consensus, creative collaboration, or validation. Code reviews, close to our hearts and minds, right? Where agents debate the implementation approaches. Strategic planning, when different perspectives must be considered. Any situation where the answer emerges from discussion, not computation. The beauty of this pattern, humans can jump into conversation seamlessly. You are not like steering agents, you are collaborating with them in this particular situation. Here is visualization of this park development story. You clearly see that on top of everything, there is group chat manager, and this agent basically orchestrates dialogue between all other parties. Next one, handoff. This is dynamic delegation in action. Imagine customer approaches the bar with a quite complex request. I need something festive, but I'm allergic to, let's say, citrus. I'm watching my sugar, and it needs to pair with spicy food. Our generalist bartender evaluates his request or her request and immediately recognizes, well, this is beyond my standard menu knowledge. I need a specialist. They hand off to allergen specialist agent who understands ingredient interactions and substitutions. The allergen specialist crafts solution, but suddenly realizes that sugar requirement needs the nutrition expert agent. One more handoff, right? The nutrition expert might pass to the food pairing agent for spicy food match as it was requested. So each handoff is not just formal, it's intelligent. Agents know their own limitations and know which colleague can help. It's like a great customer service experience where you don't get bounced around randomly, right? Back and forth. You get escalated to exactly right expert. Many customer support systems use this pattern extensively. Like the triage agent handles basic queries, but recognizes when to hand off to, for example, technical support versus billing versus account management agents. Each agent documents what they've learned, so the next agent has context. Super important idea here. This pattern excels when you can't predict the expertise needed upfront. There are lots of uncertainties in many agent systems, right? Customer queries that could go literally anywhere. Medical diagnosis that might require different specialists. Investigation workflows where each clue points to different expertise. The key is agents must be, first of all, self-aware enough to recognize their limits, and second, knowledgeable about other agents' capabilities to make smart hands-off, not just random pass-out. No infinite loops, no dropped balls. Here's visualization of this hands-off agent, and you see multiple hands-off are here, including escalation to customer support employee. Here we go back to the idea about human in the loop. And last but not least, pattern 5, magentic orchestration. And don't mess up with magnetic. It's not about magnets at all. It's magentic, and basically this is about still it's kind of multi agentic orchestration. Even though we all these partners were about multi-agents, this one is kind of the most sophisticated one, and you will see why. This is real Swiss Army knife, the pattern for when you don't even know what pattern you need, literally. Friday, back to our bar. Friday afternoon, your bar gets a call. Okay, we are bringing 50 VIPs for private event tonight, so super fast. They have, let's say, very different preferences. Just make it amazing. And this is where we need Magentic Manager Agent. Unlike other patterns with kind of predetermined flows, this manager dynamically builds a plan. It starts by consulting available agents. Inventory agent, what do we have? Events agent, what space is available? Staffing agent, who can work tonight? Based on responses, the manager builds task ledger. Check inventory levels, identify gaps in premium drink components, contact suppliers for rush delivery, schedule additional stuff, design custom menu based on available ingredients, prepare VIP area, and here's the magic. This plan can evolve. Supplier can deliver, the manager adjusts, maybe consulting the creative mixologist agent to work with existing inventory. VIPs arrive early, well, let's reorganize task priority dynamically. It's designed for open-ended problems where the solution path isn't known upfront. Think incident response where you don't know if it's network issue or database problem or code bug until you really investigate. And the manager maintains a living document, task ledger, that shows current plan, what's been completed, what's in progress, and what's blocked. It's transparent, auditable, and adaptive. This is super important. Real world example, back to this incident system. Site reliability engineering. When a service goes down, the Magentic manager coordinates diagnostic agents, infrastructure agents, rollback agents, communication agents. They build and adjust recovery plan as the situation unfolds, because it can go into completely unpredictable directions, right? This is your pattern for the unknown unknowns, when the problem space is too complex or dynamic for kind of predetermined workflows. And this visualization shows very important distinction from all previous patterns, right? It's ledger. This is where we plan, track progress, track blockers, and react accordingly. Now, for a second, let's go outside. Let's look at what other bars in neighborhood have. Can our agent communicate with the agents from the different bars? And if we map it to our IT terminology, can agents from one, let's say, ecosystem, maybe cloud hyperscaler or domain level or whatever kind of guided boundary, fruitfully collaborate with agents from totally different areas, right? I mean, built using different technology, residing on different clouds, etc., etc. Before agent-to-agent protocol appeared, was kind of invented, not that long time ago, by the way, it was a real problem, right? Because all agents were super different. But now we have this protocol that is, first of all, open standard, adopted by lots of companies, including Microsoft, of course, that allows assistants to collaborate effectively. It's literally common language for very different agents to interact. And it defines many things, starting from agent discovery, right? So one agent knows which agents available in different bars in our metaphor, or in different systems if we go back to real world. And yeah, unfortunately, yeah, this is not a topic for our today's session. I think it deserves maybe even separate conference, because it's so huge and so fast develops. But let's go back to our multi-systems and let's see what do we have in the wild. Let's remain outside of our bar metaphor for a couple of slides. In financial trading, risk assessment agents work alongside the trading execution agents and compliance monitors. They use concurrent patterns for analysis, handoff pattern for escalation, and sequential patterns for trade execution. This is area where milliseconds matter, right? And multi-agent system deliver this speed. Smart logistics orchestrates route planning agents with inventory trackers and delivery coordinators. One of the best examples here is Amazon's warehouse robots. Basically, there are physical agents in multi-agent systems coordinating to fulfill your order. Healthcare leverages diagnostic agents working with treatment planners, drug interaction checkers, etc. IBM Watson's cancer diagnosis system uses multiple specialized agents, each trained on different aspects of oncology. Manufacturing synchronizes quality control agents with production schedules and predictive maintenance agents. Best example here is Tesla factories. Tesla's factories, they run on multi-agent systems coordinating thousands of robots and processes. Gaming AI creates immersive experience with strategy agents, tactical agents, resource management agents, etc. Every compelling AI opponent you face in the games is likely kind of multi-agent systems. And incident response, like this site reliability engineering example, this is where I think all possible patterns come together. Diagnostic agents identify issues, infrastructure agents implement fixes, rollback agents restore service, and communication agents keep stakeholders informed. These are not just prototypes. These are production systems processing millions of transactions, making split-second decisions, and evolving continuously. This is present and future of AI systems. Now, let's have one more honest conversation. Challenges. They exist, for sure. Running multi-agent bar isn't all about cocktails and celebrations. Coordination complexity is real. With 5 agents, you have potential for conflicts, race conditions, infinite loop, where agents keep passing work back and forth. We learned this hard way, and now we can provide circuit breakers and timeout mechanisms. Communication overhead can kill performance.
Koska minä huomasin, että tulitte kotiin.
Every agent conversation takes time. In our bar, agents chat brings customer waiting. You need to balance collaboration value against latency costs. Context windows, they are still limited, right? They are growing, but still limited. And each agent has finite memory. When the, for example, mixologist hands off to the cashier, what information goes along? Too much and you overwhelm context window. Too little and the agent lacks necessary information. Fault tolerance requires thought. When your inventory agent crashes during Saturday rush, as in our example, can other agents compensate? You need graceful degradation strategies. Maybe the bar runs with limited menu rather than closing. It's still better than complete close, right? And security becomes complex. Well, oh yes, each agent needs appropriate access. Your mixologist shouldn't access cash register. Don't touch this. Your cashier shouldn't modify recipes as well. But they all need to share, for example, customer information. And getting these kind of relationships is crucial. And observability. Debugging distributed systems is very hard. When something goes wrong, was it agent A or agent B or their interaction? Yeah, you need comprehensive logging, monitoring, and tracing. Of course, this is not unsolvable. Microsoft's patterns and tools address each challenge. Best practices. After helping dozens of enterprises build multi-agent systems, we distilled key practices for success. Start simple. Don't architect a nightclub when coffee shop will do. Begin with 2 agents in a sequential pattern. Prove the value, then expand. Complexity is easy to add, hard to remove. I believe we all know that. Define clear roles. Each agent should have a precise job description. Prompt engineering for the win. Ambiguity leads to conflicts and gaps. Mixologists makes drinks, period. Nothing else. They don't handle payments, just these ones. Choose patterns deliberately. Sequential for dependent workflows. Concurrent for parallel perspectives. Group chat for consensus. Don't overuse magentic orchestration just because it's cool and advanced. Use it only when you need adaptive planning. Testing. Test agents in isolation before integration. Can your cashier agent handle edge cases alone? Test it. Make sure it works. And only then test integrations. And only then test full system, because each layer reveals different issues. Monitor everything: agent performance, communication patterns, failure rates, latency. You can't optimize what you can't measure. Production systems, like real ones, generate gigabytes of telemetry data daily. Plan for failure from day one, because failures happen. What's your graceful degradation strategy? How do you handle agent timeouts? What about cascade failures? Build resilience before you need it. And security, back to security. It isn't optional. Implement authentication between agents, encrypt sensitive data in transit, follow principles of least privilege. Back to old software engineering security practices, because one compromised agent shouldn't compromise your entire system. And remember, chain is only strong as its weakest link, but when we multiply chains, we create safety net. Now, back to one of the points from my previous slide. How do we actually choose proper pattern? Well, that's simple. You need to start from asking yourself the questions. Is your workflow predictable, or does it emerge dynamically? Can your tasks run in parallel, or must happen in sequence? Do you need consensus, or can agents act independently? And is your problem well-defined or open-ended? Based on these questions, you can build your own decision tree. For sequential, use it when you're building a pipeline. Like pipeline, this is keyword here. Document processing, content moderation, think about assembly line. Each steps built on the last. For concurrent, use it when you need multiple perspectives fast. Analysis tasks, content generation, validation scenarios. This think focus group, everyone shares their view simultaneously. For group chat, use when consensus matters. Design reviews, strategic planning, complex troubleshooting. Think team meeting. Discussion leads to decision. Handoff. Use when expertise requirements emerge during processing. Customer support, medical diagnosis, investigation workflows. Think emergency room. Triage, then specialist. Magentic, well, use it when you don't know what you don't know. Incident response, research tasks, creative problem solving. Think kind of detective work. Follow clues where they lead. And remember, these patterns can be combined, and basically they are combined in many real life systems. Maybe you use sequential for data preparation, then concurrent for analysis, then group chat for decision. The patterns are tools in your toolkit. Use the right one for each job. Let's talk about future a bit. Where are multi-agent systems heading? Imagine walking into a bar where team self-organizes based on tonight's crowd. Busy night, agents spawn specialized helpers automatically. Quiet evening, they consolidate roles efficiently. This is emergent behavior, teams that adapt without human intervention. Cross-domain collaboration is coming, thanks to, in particular, agent-to-agent protocol. Your bar agents will collaborate with supplier agent, the delivery service agent, even the customer personal preference agent. It's not just multi-agent, it's a multi-organization, multi-domain, multi-cloud vendor agent collaboration. Self-healing system will detect and correct problems automatically. For example, mixologist agent showing signs of some drift, others can compensate while it retrains. Communication bottleneck detected, agents reorganize their interaction patterns. Human AI teams will become seamless. You won't use agents. You will work with them as a human employee. They will participate in your Teams channel, join your video calls, collaborate on your documents. The boundary between human and AI teammates will blur. And adaptive patterns are emerging while the orchestration itself is dynamic. Systems that start with sequential, for example, recognize inefficiency and restructure on the fly to concurrent, and pattern selection becomes another AI decision. That leads us to the bar of the future. It doesn't just serve drinks. It anticipates needs, personalizes experiences, optimizes operations, and evolves continuously. And it never ever closes. And this is not science fiction. Microsoft, Google, OpenAI, many other companies, they are building these capabilities now while I speak. And the future is closer than we think. Now, let's get a bit practical. Just a couple of slides to unlock your technically. How do we actually build this? Microsoft's semantic kernel framework makes it surprisingly straightforward. Look at this code. It's almost as simple as describing what you want, right? It looks like more like prompt than a code. First, you define your specialized agents. Each agent gets a name, instructions, and tools. For example, your mixologist knows recipes and has creativity tools. Your cashier understands payments and has access to point of sale system. Then, and this is very beautiful part, you choose your orchestration pattern with just one line. Want sequential? Just say sequential orchestration. Need concurrent? Concurrent orchestration for salvation. It's that simple. The framework handles all the complexity: message passing, state management, error handling. You focus on what makes your agents unique, not all the plumbing around. And here's the kicker. The same code pattern works across all orchestration types. Switch from sequential to concurrent, just change one line. Add new agent, drop it into this team. Need to debug? Each agent can be tested independently. It's available today both for Python and .NET. And you'll find lots of examples in Microsoft's GitHub repository, including complete working implementations that you can take, clone, and adapt. And we are talking about going from concept to working prototype in just hours, not days, not months. This unified interface means your team can experiment rapidly, try different patterns, different agent combinations, different models, all without big rewrites. And also, we have what we call solution accelerators, ready to go, complete cloud solutions that follows all possible best practices. And multi-agent custom automation agent, like long name, this is one of these solution accelerators. It manages a group of AI agents to accomplish tasks based on user input, powered by semantic kernel. And it's not only agentic pattern, it's also full cloud pattern that you can deploy with just one command of Azure Developer Tools CLI. Last call, right? Let's finalize a bit. So what we've learned. First, specialization beats generalization at scale. One super smart agent sounds appealing, but specialized teams deliver much better results. It's why hospitals have specialists, why companies have departments, and why your multi-agent systems should too. Multiple agents are greater than one super agent for complex tasks. Not always, sometimes single agent is perfect. Don't over-engineer, right? But when complexity scales, teams scales much better than individuals. Different patterns solve different problems. There is no universal best pattern. Sequential for pipelines, concurrent for perspectives, etc., etc. Parallel processing equals better performance. While one agent thinks, others act. This isn't just faster, it's fundamentally more capable. Fault tolerance through redundancy. In single agent system, failure is catastrophe, right? In multi-agent system, it's manageable. The shows go on. And finally, start simple, scale intelligently. Don't build complexity you don't need. Start with 2 agents, prove value, then expand. Evolution beats revolution. And remember, back to our bar, the best bar isn't run by one superhero bartender. It's run by a well-coordinated team where each member excels at their role, supports their colleagues, and contributes to experience greater than individual could provide. My call to action. Folks, let's continue our conversation. Connect with me on LinkedIn. Follow latest
excuse me,
agentic
sorry,
AI advancements in my feed.
Maxim.
Yes?
Sorry for interrupting. We just need the time. Are we close to the ending the session? Because we have to prepare.
This is my final slide. Yeah, we are here.
Yeah, good. Thank you very much. Thank you. Sorry for interrupting. Continue.
Yeah. again, I will explain how to build agents and which patterns to use. I'll share everything I know about use cases and our libraries. And also you can get this deck immediately. And I hope that's useful for you because it contains patterns, links to useful resources, documentation, and everything. Thank you so much. If you have time, I am open for your questions.